topic is criteria for selection of circuit breaker for a substation. So while selecting the circuit breaker, we have to consider certain criteria so that we can properly select the circuit breaker, like circuit breaker for the substation. So the circuit breakers are one of the most critical components, of the substation, and their primary function is to safely interrupt fault currents and protect the equipment from damage. Proper selection of the circuit breaker ensures the system reliability, safety, and continuity for power supply. First criteria to consider on the basis of the rated voltage. We know the rated voltage of the circuit breaker must be equal to or greater than the highest system voltage. It should be equal to or greater than the highest system voltage. First, you have to be apprised of the nominal system voltage. What is your nominal system voltage? The selection of the circuit breaker with standard rated voltage should be higher than the maximum operating voltage, taking into consideration of insulation level and impulse withstand voltage. The below table gives the system voltage and their rated breaker voltage. For 11 kV system voltage, 11 kV, its breaker rated voltage is 12 kV. For 33 system voltage 33, the breaker rated voltage is 436. Similarly, if system voltage is 132 kV, your breaker rated voltage is 145 kV. If this is 220, if this is 220, then the rated voltage is your 245. The underrated voltage may lead to the insulation failure. If we take the underrated voltage of the circuit breaker, it may cause insulation failure or and flashover during the switching operation. So next criteria on the basis of rated current. The rated current is the maximum continuous current the circuit breaker can carry without exceeding its temperature limits. First, the load current is calculated by using the working formula, that is the load current I is equal to MVA into 1000 divided by root 3 kV system voltage. Due to the load current calculation, the future load growth 20 to 30% is also taken into consideration. Then the higher standard breaker is selected. The available standard current rating of the circuit breaker maybe your 630 ampere or 1250 ampere or 1600 ampere or 2000 ampere or 3150 ampere or 4000 ampere. For example, for a 20 MVA and 33 kV transformer, the load current is approximately 350 ampere and the standard rating of the breaker is 630 ampere. An undersized breaker may overheat if you take it undersized below 630 ampere. It may overheat and reduce the equipment life. Then third criteria on the basis of our braking capacity. It is also known as your short circuit braking current. The braking capacity, the braking capacity is the maximum fault current a circuit breaker can safely interrupt. And the short circuit level at the installation point is calculated, and the braking capacity must be greater than the calculated fault current. The braking capacity must be greater than the calculated fault current. We may use the following working formula to calculate the desired short circuit level. The short circuit MVA is SC, that is root 3 V ISC. ISC means fault current. V is the system voltage and ISC is the fault current in kiloampere. And the common ratings are 25 kiloampere, 25 kiloampere, or 31.5 kiloampere, or 40 kiloampere, or 50 kiloampere. If the fault level at a 33 kV bus is 31 kiloampere, we select the breaker rated at 31.5 kiloampere, or we may select it at 40 kiloampere. Insufficient braking capacity can result in catastrophic breaker failure during the faults. So this should be properly adhered to. And next basis is your making capacity. The making capacity is the peak current that the breaker can withstand and close onto during the fault condition. According to the IAC standard, the making capacity is approximately 2.55 times of braking capacity. A breaker with 31.5 kiloampere braking capacity, its braking capacity should be your 2.55 into 31.5, that is 80.3 kiloampere. The braking capacity should be 80 kiloampere. Braking capacity must be your 80 kiloampere, and during the fault closing, the extremely high electromagnetic forces are reduced, and the breaker must withstand these forces without damage. So properly, the making capacity rating for the making capacity should be properly maintained. Otherwise, the breaker must withstand these forces due to heavy electromagnetic forces. Produced during the operation. So proper rating of the making capacity should be maintained. Next one is your operating mechanism. The operating mechanism provides the basis, provides the energy required for opening and closing the circuit breaker contacts. Different types of breaker mechanism with their preferred advantages give a basis for proper selection of the breaker mechanism. What are they? They are our spring operated mechanism. This is used for most common in modern substations. It is reliable, low maintenance, and suitable for medium and high voltage applications. Next, your hydraulic mechanism used in some ESV substation, extra high voltage breakers, high operating horse, requires regular maintenance. Hydraulic. Then pneumatic type mechanism uses compressed air, fast operation, and less common in new installations. Most modern mechanism or motor charged spring mechanism. A spring is automatically charged by a motor, and it is widely used for modern SF6 and vacuum circuit breakers. The selection of the circuit breakers with a preferred reason is considered on the basis of reliability. So the proper mechanism uh, is considered on the basis of reliability requirement and frequency of operation, availability of auxiliary power, maintenance requirements, remote control, and automation needs. On this basis, we can uh, uh, select the proper mechanism. For the most modern 11 kV to 220 kV substations, motor charged operated SF6 or vacuum circuit breakers are preferred due to high reliability and low maintenance. So for a typical 33 by 11 kV utility substation, commonly selected breaker are have rated voltage is 36 kV, rated current is 1200 pt ampere, braking capacity is 20 to 31.5 kiloampere, and making capacity is 63 to 80 kiloampere peak. So at last, we conclude that on the basis of these criteria and as per our needs, we can properly select the circuit breaker installed in the substation. And these topics is all about the selection of criteria of circuit breaker, which gives us clear idea for proper selection of the circuit breaker. And for today, this much, and see you again in the next class. Thank you.